We're live, all right. Hey, so in 8.1, you guys, like I said, we're going to start looking at some right triangle trig, which I know you've had some exposure to. And we'll talk about this. I think you probably talked about sine, cosine, tangent. I'm not sure you've talked about all 6 functions. You guys are pretty familiar with the first 3. But question today is this: how can you find a trigonometric function of an acute angle? This symbol is theta right here. Anytime you see theta, this is a Greek letter theta. Theta is going to be used a lot in trig. It's an unknown, okay? This is like your unknown. Guys, you're usually used to putting what down for unknowns?
X.
Okay. When we're talking about angles, they're not going to use x most times. They're going to use what? So theta is like a what? It's like an x. Okay, so just keep that in mind today. Theta is going to be like an x for us when we look at this stuff today. Okay? So right triangle trig, one of the angles always has to be how many degrees, kids?
90.
90 degrees. So our job, in order to answer this question about trigonometric functions of an acute angle theta is this. We've got to be able to evaluate trig functions of acute angles. We're going to find unknown side lengths and angle measures of right triangles. And then we're going to use the trig functions to look at a few real-life problems. Okay? So you guys have seen this before. I think the first three. If I'm going to do this real quickly. Let's draw a right triangle up above our vocabulary. And let's do this. Draw a right triangle. Things I want you to understand about triangles, or at least maybe recall. Okay, does that look like a right triangle, first thing?
Yes.
Okay, here's what I'm going to do. I'll make that a right angle right there. Okay, and I'm going to label my right triangle A, B, C, like so. So this will be A here. This will be B. And this will be C. Okay. You guys okay with that? Okay. When we start talking about trig, first of all, trigonometry is a study of what trig? Triangles. Okay, there's going to be a lot to do with triangles. We know a lot of things about triangles. You know Pythagorean theorem. You know some of these trig functions up here, okay? But the thing I want you to understand about this is this. Anytime we deal with an angle, we always label an angle with what type of a letter? Lowercase or capital? Capital. Now, when we label sides relative to angles, we're always talking typically about a side that's opposite. So for instance, if A is down here, which segment's opposite of angle A? B to C. So we say for a side length, this would be little length A. So you'd have a little A here. What would go down here then? Little b, that length is length b units because it's opposite of what angle? And then what are we going to call the hypotenuse then? Little c. Okay? So you always talk about side lengths as they correspond to angles in terms of that side kind of being opposite of the angle. Okay? All right, guys, so we've got these vocab terms. We've got 6 types of trig functions. The first one's called the what? Usually denoted by sine of what? Theta. Sine of theta would be the opposite over the what? Okay, let's just pretend that angle A is the angle I don't know down here. Let's call this angle theta down here. The measure I don't know is theta. So in this case right here, if theta is the angle I don't know, what angle am I really referencing? Angle A. Okay? So what's the sine of theta going to be if the definition's an opposite leg over the hypotenuse? Okay, it would be A over C in this diagram, right? Okay? Then what's the definition of a cosine? Okay? Adjacent leg means it's the leg that's touching the angle. So what leg is touching the angle? B over the hypotenuse of what? C. Okay? And in fact, maybe it's beneficial for me to go through and label these. What kind of leg is A, kids? Is this an opposite leg here or adjacent leg to our reference angle? So this would be the opposite leg of theta. What would B be? So I always abbreviate adjacent leg as AL. Okay, and then what's C going to be then, kids? C is going to be my hypotenuse, isn't it? Okay, what's the definition of tangent, kids?
AB.
Okay, so it's the opposite leg over the what? Adjacent leg. So in ours, it would be, did you say A over B again?
Yeah.
Okay, now, here's the tricky part of this. Okay? Before I go on to the next one, raise your hand. Just tell me. You guys remember sine, cosine, tangent, or at least hearing about it before?
No.
No?
No.
Never heard of sine, cosine, tangent?
No.
Sokotoa?
No.
stands for the sine is the what over what?
Opposite.
Opposite leg over hypotenuse. Cosine is the what? Adjacent over the, and TOA would be what? Tangent is opposite over adjacent. That'd be one thing to remember, SOHCAHTOA. If you can remember that, sine is an opposite leg over hypotenuse. Cosine is an adjacent leg over hypotenuse. Tangent is the... Okay, now, here's what I'm concerned about. Okay, these might be kind of new for you. Cosecant, secant, and cotangent. Ooh, don't. Okay, let's talk about cosecant. What's cosecant say it is? The hypotenuse over the what? I know my drawing's off the board right there, kids, but what was the hypotenuse? C over? Guys, quick question. Which one was A over C to begin with, those top three? Sine, right? Okay. How is the cosecant related to the sine if... Okay, so it's the reciprocal. So the cosecant, you might want to write this down, is the reciprocal of what? Yep, the cosecant is going to be the reciprocal of my sine. Okay? Secant is defined by what is what over what, kids? Okay, well, what is the hypotenuse length? C over the adjacent. Okay, this is a weird one. I don't know why they did this. Makes no sense to me. But secant is really the reciprocal of what? The only one that makes sense to me is cotangent. That's the reciprocal of what? Tangent. Okay. It would have been nice if the ones that started with C were reciprocals of each other, but are they? And the ones that started with S were reciprocals of each other, but are they? No. No. Okay. Cotangent. What's the cotangent going to be, kids? So it would be B over A, and isn't that the reciprocal of my tangent, friends? Yeah. Okay, so right down here, maybe a way of thinking of cotangent is it's the reciprocal of what again? Okay. First 6 terms, are we okay on those? That's my first question. Okay, I mean, these are just definitions, okay? And they're definitions for the lengths, or the ratio of lengths of right triangles, okay? So guys, I don't think these next terms are too pressing. Right triangle, any triangle with what? 90-degree angle. We know what a hypotenuse is, right? Okay, I know I'm going quickly, but are you on board with me? Okay. Acute angles, kind of like your teacher. That's even better than that.
That was pretty good.
That was. Angles less than what? 90. Dude, I'm less than 90. I don't even get 100. What is that all about? I thought I was perfect.
You are in our eyes.
Okay, that's all I needed to hear. Acute angle, any angle less than what? 90 degrees. Pythagorean theorem, in a right triangle, a squared plus b squared is what? A and b are my what? They are the legs. C would be the hypotenuse there. Yep, I'll abbreviate there. I'll get out of the way so you can write that. Reciprocal, we already talked about that, is flipping the numerator and what? Denominator. Okay, complementary angles. This is kind of an interesting one. Complementary angles are 2 angles that add up to what?
90.
Okay, in our right triangles, what's one angle, kids? 90 degrees. Okay, how many total degrees are in our triangle? So if one of the angles is 90 degrees, the last 2 must add up to how much more? 90. Okay, so I'm going to say this. In a right triangle, your the two acute angles add up to 90 degrees. Okay? So in a right triangle, one angle is 90 degrees, which means the sum of the remaining 2 must also add up to how much then? Because you want the 2 to be 90 plus the 90-degree right angle, the total sum of how many degrees in a triangle? 180. Very good. Okay. All right, now I'm going quickly through vocab, but do you have down what you need down right now? Anybody need to go back up on this at all? Awesome. You know what, guys? I'm already glad I made the change. Well, I just think if you've got any college prep with me, this is the same format of stuff that we've used in the past. And the stuff that I had before just is very different from this.
Well, when I like putting trig on my schedule, I figured it was all going to be the same no matter what.
Really?
Yeah.
Well, I made that change this year, Connor.
Thank you.
You can think it was just for you.
It was just for me.
My concern was the notes. And I think that you guys like the notes format.
Yes.
Okay, let's talk, kids. This here says evaluate what, kids? 6 trig functions of angle what? Okay, so where are we referenced at? Like if I had to say this is a map, what corner are you standing on? Angle what? So where am I standing? Yep, we are where? You are right here, aren't you?
Yeah.
Okay. Well, kids, do we know the legs in this?
Yes. Yeah.
Do we know the hypotenuse?
Yes. No.
Don't know it right off the bat.
Figure it out.
We can figure it out. Anybody know this Pythagorean triple, 724? Okay, you'll get used to all these triples. You'll get used to like, ooh, that's 724. I know that's going to be, you're going to see a lot of practice with these. If I didn't know the hypotenuse, how would I find that? Yep, we go a squared plus b squared c squared. Who said that?
25.
Help me out with Sarah. What plus what first?
7 squared.
Yep.
Plus 24.
Yep. And we're going to call it hypotenuse c. Is that okay?
Equals
All right.
625.
So this is 625 when you punch it up on the left. That's convenient because 625 is a perfect square. C is what value? 25. Now kids, I'm going to be honest with you. When I have to find the 6 functions right here, this is what I like to do. We know that C is 25 here for a hypotenuse, right?
Yep.
I usually go in the order of sine, cosine, and tangent. And then just over to the right of them, I do the opposite. I do the cotangent here. Okay, the tangent and cotangent, those are easy to keep together, right?
Yeah.
Okay. Just remember for sine and cosine, the ones that kind of reciprocate each other, the C and the S kind of flip. Okay? So what I do here is this. If I did sine up here first, then sine is going to be the reciprocal of CSC. What's that going to mean, kids? And then the cosine, its reciprocal would be secant. So here I go, I always go sine, cosine, tangent, and then I'm like, okay, then the C and the S have to switch, and then this is just cotangent down here with tangent.
Nobody likes the SEC.
I don't either. Okay. Although Alabama's a sleeper team, and no one's talking about them.
For basketball?
Yes, they
I
are.
was going to say, I don't know if you're talking about football.
Football. Good
They're
job.
not a sleeper in that.
Oh no. Okay. Guys, what's the sine function here? What's the ratio of the sine? 7/25. Think careful on that. What's the definition of sine again? Okay, so opposite relative to which angle, kids? Okay, so what is opposite of theta, kids? And one thing I might tell you is this. Maybe you want to get in the habit of labeling stuff. This is the opposite leg. So what's this have to be then? The adjacent leg. And then this is they already put it up there for you. Okay, so not 7/25, but 24/25. Now if they ask you to turn that into a decimal, what are you simply going to do? Divide. Now I like doing it this way because if I know the sine's 24/25, what's that mean about the cosecant right off the bat? 25/24. It's the reciprocal of that, right? Okay, help me with the next row. Cosine and secant. 7/25 and what else? 25/7. 25/7. 25 wins, 7 losses. That's about a Hawkeye record, isn't it?
I literally have
How about your tangent? 24 over what?
7.
24/7. We're going to do trig 24/7, right? That shot me. That hurt. Guys, when you do trigonometry 24/7, you're going to get a nice what? Going to get a nice
Headache.
just in time for spring break, right? Okay, what's your cotangent going to be, friends? Okay. Guys, are we clear on that part? We've done stuff like that in the past. This should be a review for you right now, kind of coming back to you right now.
When are we supposed to learn
I
that?
never did.
We had
What's that?
when we were online.
Are you sure?
We did it in college prep last year. When was this covered in the past question mark?
I don't know. It should have been covered in.
We had one week of it.
You should have had an integrated one with.
No, we
Yeah.
had.
Yeah.
Yes, we haven't.
No, last year during quarantine.
Yeah, we had like one week of it. When we
Really?
were online.
Okay. Well, hang in there with me, okay? Are we good on identifying the 6 functions? Okay, are you good when I say this? If I do sine, cosine, tangent, I just remember to flip the C and the S the other direction here. Cosecant's the reciprocal of what again? Secant's the reciprocal of, and cotangent is the reciprocal of, or vice versa. Okay, guys, I think you should put in a star by example 2. Okay? This is where things start to get a little interesting. Understand this, every triangle we're working with in this first section is what type of a triangle.
Right.
So if you're not sure where to even start, the first thing you can at least do is draw a, let's do that real quickly. It says first of all, in a what up here, kids? In a right triangle. I'm going to draw this right now. I'm just going to make a right triangle. How about like that? Do that first.
Is this hard drawing a right triangle is?
Not that hard. Thanks.
Hey, you need the little thing.
Oh, I do need a little thingy, yes. I hope you meant by little thingy, you meant right angle symbol. Okay. All right, so it says right here, in a right triangle, theta is what kind of an angle? Acute. I'm just going to pick theta to be right down here. Okay? It says theta is an acute angle and the sine of theta is what, kids? Okay, here's the situation. If the sine of theta is 5 over 6, this is what we need to really talk about. How is sine defined again?
Oh, over 8.
So the opposite leg length over the... So when I say the sine of theta is 5 over 6, this is like saying opposite leg length is what value? 5. And the hypotenuse is what? 6. Okay. So that 5 could go right here, couldn't it, kids?
Yeah.
And the hypotenuse of 6 could go right there, couldn't it? Okay? And we're told that the sine of theta is already what, kids? Isn't it 5 over 6? Okay, so remind me again, which function is the reciprocal of sine? Cosecant, right?
Yeah. Why do I never remember that?
You'll get it. You'll get it. Trust me, you'll get it.
I don't ever remember that.
I'm going to back up here. This should say cosecant of theta then. So if sine's 5 over 6, what's that make the cosecant?
They got knocked over buzz. They hit the wall so hard.
Okay?
He really fell over. He's like kicked the wall or something.
Okay, it's the cosine of theta. Oh boy. I don't know the adjacent leg length here.
Well, we can figure it out.
We can figure it out. I'm going to call this B down here. Is that okay? Is that okay, kids?
Yeah.
So by this right here, wouldn't 5 squared plus B squared have to equal 6 squared? So this is 25 equals what value? What are you going to do next? So B squared has to be what value? So what's that make your B value? Root 11, right? Okay, so this adjacent leg length to our reference angle theta must be what length?
I go to the bathroom.
Okay, so I just want to take a time out right here. Once you guys get to that point, I just want to discuss what we're at, where we're at, why we're there. Guys, we knew right off the bat what?
5, 6.
Sine of theta was 5, 6, which meant you could automatically find a cosecant, which is just the... Okay, now I drew a picture over here. Do you understand why did 5 go over here?
Because it's the
Opposite leg length, because that's part of the definition of what the sine is. The opposite leg length up here would have been 5. Hypotenuse would have been 6. What theorem did I use to find that other leg then? Okay, once I know it's root 11, can't we go through and figure out the rest now?
Yeah.
So help me with the cosine of theta. What over what? So what's adjacent to theta down here? Hypotenuse. Wouldn't it be 6?
Yeah.
Okay. Now I want you to put a star by the secant right here, kids. What are you going to get for this? 6 over what? Okay, now there's this whole thing about square roots in the denominator. Okay? This first of all, is 11 a perfect square or not?
No.
And when I say it's not a perfect square, more than likely it's irrational. And they don't like to have an irrational denominator. So what we end up doing is multiplying by a form of 1. We call this 6 root 11. You guys remember how to rationalize denominators? What's the denominator down here? So we multiply both the top and the bottom by root 11 again. And let me show you why. This will be 6 root 11 up top, wouldn't it? But what's root 11 times root 11 going to get you? Well, root 11 times root 11 becomes root 121, which is just what value again? 11. So when I take one root times the same root here, it's just what value in the denominator. So the secant right here, the secant of theta then, I'm gonna say that this is really equal to 6 root 11 over what? Okay. That's kind of a goofy one. You don't want square roots in the denominator. Okay? Alright, how about tangent then? 5 over root 11, but there's that idea again that
So 5 square root over 11.
there's that idea where I've got a square root in the denominator. Do I want that? So what am I going to multiply both the top and the bottom by again? So this will equal 5 root 11 over what, kids?
What?
Agreed?
Yeah.
Okay, now, guys, don't lose sight of what you had right here. Can I reciprocate this to get the cotangent right off the bat?
Yeah.
Yeah, just the reciprocal of 5 over root 11 for my cotangent of theta would be what? Root 11 over. Do I need to do anything to that one?
No.
No, because I've got a whole value down here in the denominator, right? If I give you one of the functions in a right triangle, kids, in this case, sine of theta was what? Can you find the other 5? Okay. This is what you knew right here, right? Even if I had no idea about where to go, we know we're dealing with what type of a triangle. Draw a right triangle, put your dimensions in, and then work with it from there. I think that's the best thing that you can do. Okay? Holy smokes, kids. We're coming along here today. Thank you, Sam, by the way.
7. It's 9?
You know, being in her first hour is really nice.
Yeah, it's so 9.
In the
This
morning?
isn't first hour.
This is second hour.
Oh.
It's the first hour after the first hour, though.
Yeah.
Correct.
I have gym first hour.
Okay.
We can make it extra too.
All right, kids. Next one right here says this. It says find the value of x for the right triangle. Now, kids, one thing I'm going to give to you probably tomorrow is going to be what's known as. You guys ever heard of a unit circle?
Okay.
You ever heard of a table of trig functions at all? Okay. Do this for me, kids. Type in your calculator. This is. Shoot. How do I want to do this? Okay, I'm going to do this for you real quick. We're going to talk about this chart here in a little bit. In fact, maybe I'll just bookmark it and put it on the web page for you today to use. I'm going to throw this chart up here for you kids. Okay, you guys see this chart right up here? We're going to talk a lot about stuff right here, okay? We talk a lot about, first of all, everything we're dealing with is in degrees. We're going to be headed to radians a lot this trimester, but degrees is what I'm worried about right now, okay? Guys, in example 3, what's the angle that's referenced in your triangle? That's not the right angle. What's the acute reference angle? 30 degrees, okay? And guys, 30 degrees right here, they give you a sine value for some of these special angles. They give it for an angle 30 degrees, 45, 60, and 90. Is 30 one of our special angles according to this chart?
Yeah.
And you'll know more why here down the road, but if I gave you a special chart right here like this, let me just ask the question, what's the tangent of 30 degrees according to this chart? What, root 3 over 3, okay? So there's going to be times where special angles come up, and I'll get a special angles chart up here. I don't like this one. I'd rather have a better one than this, but actually this is pretty good. So let's just go back to this chart, or this example, I mean. It says find the value of x for the right triangle right here, and we're going to find the exact value of this, okay? Here's what I'm going to point out. 30 degrees right here is our reference angle, okay? How is x related to that? It's the adjacent leg. How is 12 related to that reference angle? Okay, thinking about SOHCAHTOA, which of the 3 trig functions, sine, cosine, or tangent, is going to involve my adjacent leg and hypotenuse? Not cotangent.
Secant.
It's cosine.
Cosine, right?
Oh, no.
Adjacent and what?
Hypotenuse.
Okay, think of that one right there, okay? All right, so here's the deal. I'm going to set this up as follows. We're going to call this the cosine of what, kids? What's the angle down here that we know? 30 degrees. By definition, that would equal the adjacent leg length of over. Okay. Now, kids, the idea here is this. A couple of ways to do this. Okay, we're going to do this as an exact value first. It turns out 30 degrees is considered a special angle in trig. All right? And really, kids, when we're dealing with right triangles, the only angles I'm really concerned about are 0 degrees, 30, 45, 60, and what? Okay. How did I set that up? What trig function did we use? I said cosine of 30 degrees. What the heck is the cosine of 30 degrees here, kids? Its value is root 3 over 2. So here's how we set this up, kids. We replace that cosine of 30 degrees with that table, root 3 over 2, and set that equal to. Now you kids that were just in Carl's prep. Oh, that's a rational function, right? Rational equation. What are we going to do with this? Cross multiply. We would have 2x equal what? Right? So what am I going to divide both sides by now? What do we get x equal to, kids? That's 12 divided by 2. So 6 times the square root of 3. Okay? Now if do you guys remember talking about 30, 60, 90 right triangles with probably Mrs. Hilt last year?
No.
Do you?
No.
No? Yes?
A
No?
little bit.
No. If Phil taught it, then no.
I remember what she taught.
I remember getting yelled at.
I loved her.
How'd we go?
Yeah. People live in Vermont. You gotta sit under her desk.
I'm pretty sure she's playing it safe
rest of
and not
us got
selling
scolded.
now because of that. I'm pretty sure she's high risk. So
I have her phone number.
You guys don't remember me calling her the day
Now, guys, I have a question for you. How many special angles are listed on that chart that we talked about here?
5.
Is 28 degrees going to show up on a table like this?
No.
Okay, we'll show you how to handle that. In fact, that's where I want to go next. You could do this. You could do this same problem with a calculator. If I wanted to call 6 root 3, this would be the exact value right here. 6 times the square root of 3 would be that length. But if I wanted to estimate this, I could just put this in my calculator and take 6 times the square root of 3. Okay, that's one thing. And I'm not going to get too excited about those special angles right off the bat here when we're solving right triangles. But just know that if you're working in big ideas, you might see some answers like this. And the reason they're like this is because they were based off of some of those special angles. In fact, I'm going to put down those special angle values. One special angle, the ones that you're really worried about, 30, 45, and 60 degrees. And I'll get that chart up on the website today. It'll be, you guys know the part that I have on the website that says online calculators and resources? I'll put it in there, and I'll put it in there as a special angles table, okay? And we'll have time to look at it tomorrow in class. So here's the deal. Next example is what I'm really after here. So this is where I get pretty concerned, because take a look at your reference angle down here in example 4. Okay? This is really the whole piece to this chapter, or this section in this chapter. Okay? I think this is the most important example here. It says using a calculator to solve a right triangle. So help me out, friends. What acute angle measure do they give you down there? And is 34 going to be part of that angle? No. Okay. Solving a right triangle means this. You've got to solve for all angles. And you got to solve for all sides. Okay? So here's what I like to do. I like to, for my angles, I like to put capital A, capital B, capital C. And then for my sides, I like to go little a, little b, and little c. Okay? Are there some things up there that we know already?
Yeah.
Let's talk angles first. What angles do we know? So A is how many degrees? B is? We don't know that yet, do we? We'll talk about how to figure it out. Do we know angle C down here? One of your angles in this, at least in this section, is always going to be what, kids?
90.
Okay? Let's talk about our sides. Do I know little a? Do I know little b?
Yes.
That's 13. Do I know little c? Okay. So here's the deal, kids. We need to find angle B and what else? A and C. Okay, question for you, kids. I heard some people throwing numbers out. I heard 56 is a value.
Yeah.
Why are you coming up with 56?
9 equals 124, 82 is 124.
Here's the deal. If I know two angles, then you know what? Third, because I have to add up to what? 180. So what's 180 minus 90? 90 minus 34 more is? Okay, so this must be 56 degrees right here, right? Okay? Are we good there? Okay. Now the question becomes this. Do you guys want to find side A or do you want to find side C first? Okay, let's find side A. Okay? All right, I'm going to blow this up here a little bit so I've got some room to work on side A. Take a look at this right here. What reference angle was given here? Okay, I'm going to reference everything from this angle. So it's kind of like saying you are standing right here. Okay? A would be then, wouldn't that be an opposite leg? Wouldn't this be the adjacent leg? Okay, here's the deal. Let's go from this 34-degree angle. And from this 34-degree angle, we're going to use the opposite leg and adjacent leg length of how much? 13 to help us find what? Let's see. Opposite leg, adjacent leg. Tangent function, right? So we're going to set this part up for A as the following. We're going to say the tangent of how many degrees? What angle were we referencing?
34.
Is going to equal, okay, by definition, tangent is what over what?
Opposite over adjacent.
So what's the opposite leg? Is that an expression or a value? A, right? What's the adjacent leg length to our reference angle? Okay. Now this is where your calculator is going to come in handy. And anytime you punch in a trig function, like we're going to punch tangent of 34 in your calculator, and it's going to kick out some kind of irrational decimal. Okay? I want your decimal to go 4 places for me. So type in tangent of 34 and tell me what that decimal is to 4 places.
0.674.
Anytime you turn a trig function tangent of 34 degrees in this case, into a decimal equivalency. I want that decimal equivalency to how many places?
4.
Secondly, always, always, always put that over a 1. Because it makes solving a proportion a lot easier now, doesn't it? Couldn't I cross multiply and divide the way I've set that up now to solve for A? Does A look like it's shorter than 13 or longer than 13? It looks shorter, okay? Let's give our lengths a distance to the nearest tenth here. So 8.8 you're getting? Okay. Now for C, I can kind of do the same thing. How is C related here, kids? This is the hypotenuse, right? So I could reference 34, adjacent leg, and hypotenuse would use the what? So for C, I could say the cosine of how many degrees? Equals, what's the adjacent leg length here? 13 over the hypotenuse of C, right? So what am I going to do with cosine 34 now? Find that value, right? How many places? The cosine of 34 to 4 places for me is? Going to put that over what? 1, and that's going to equal 13 over C. Now, kids, question here. What side are we looking to solve for here? We only have C up there. So it's the hypotenuse, isn't it?
Yeah.
So should that side be more than 13 or less than 13 if I'm looking for the hypotenuse? Better be more because the hypotenuse is the... When you cross multiply and divide, what do you guys get for a C value here? 15.7. You guys all agree? Now another way to have done that would have been, guys, I know both the legs, but I have done A squared plus B squared at this point equals C squared.
Yeah.
We knew both A and B at this point, didn't we? Okay, so we could have done that. All right. Guys, when they say solve a right triangle, how many angles do you have to have? And how many sides do you have to have? Quick way to know you're kind of right. Go order from smallest to largest on angles. Smallest, middle, largest, right? Same should be true of your sides. If ABC is the order from least to greatest in terms of angles, then the same should be true on sides. What's side A? The shortest side. B is 13. Is that the second length? C the longest? So this order would go ABC from least to greatest too, wouldn't it? That should always match. All right, friends. What time did we get out of here? 10:09? Yeah, I think I'm going to stop there. What do we have left? Do we have another example after this one too?
Yeah.
Yeah, let's pick it up. I apologize for not getting through everything today, but I think you've got a pretty good idea of where to start. We'll get the rest tomorrow. Now here's what I need from you guys. Okay? I need help, so when we're doing this,